Hello and welcome to another video. In this one, we're going to be making a sample CPython C extension. A C extension might be helpful if you have a bit of code that's particularly hot and you want to, rewrite it in C. However, I think there are better alternatives than writing C for Python. For instance, you could write it in, Python or CFFI if you're interfacing with an already existing library. You could even write an extension in Go if you wanted to, or a bunch of different programming languages. I've heard the new Py03 Rust bindings are pretty cool too. I haven't checked those out yet, but I probably will at some point. But anyway, I want to show you a very basic Hello World C extension and how you'll set that up with setup tools. Unfortunately, this was going to be pretty complicated, so I'm going to be writing a lot of code for this, so pay attention, I guess, or copy down the code when it's done and play with it yourself. But yeah, let's jump into it. So the first thing I'm going to do, I'm going to set up a virtual environment just because we're going to be using setup tools to actually install this. So I want a place where I can install stuff. And we're going to start by writing the setup.py first. And we're going to need two things from setup tools import setup, and we're also going to need from setup tools import extension. Extension is how we indicate to the build machinery that we want to make a special extension module. But other than that, it's mostly as normal. We're going to call our thing hello lib, and we're going to give it a version, and we are going to set ext modules. This is how you tell the setup tools machinery that it should build an extension module for us, and we're going to put an extension in here. An extension has two parts. The first is the name. Conventionally, most speed up C extensions are prefixed with an underscore. Mostly because you want to hide your C implementation away and switch out your APIs in pure Python where it's a little bit easier. And we're going to follow that convention today. Also, you will pass the list of source files. It is up to convention as to what you want to name them here. But I've found that matching the module name seems to work the best for me. So I have a list of extensions, and we're going to be naming an extension module called hello. And this should be our setup.py. Should be all that we need there. I'm actually going to open the setup.py over here just so you guys can continue to see it. And we're going to open hello.c now. So we're going to be writing some C code today. Now, when you write a CPython extension, you're going to want to include the Python headers. And the way you do that is by doing include python.h. If you're on a Linux distribution, usually they don't ship the headers by default. So often you'll have to install like python 3-dev. On Windows, they're usually there, although it's usually more difficult to get a C compiler. But there's all sorts of tricks when you have to build a C extension. But anyway, include python.h. We're going to be making just a very simple method first, and then I'm going to show you a little bit more involved but still simple method that introduces a couple of concepts. So the method that we're going to be making today is a hello world method, and we can do that by doing static PyObject star. Everything in Python under the hoods is a PyObject pointer, and you can kind of see some of the leaking implementation details. If you do like ID on an object, that will actually tell you its memory address, which is kind of interesting. And Python will sometimes reuse memory, and so sometimes ID will be the same object across multiple calls. But anyway, that's probably enough for another video at some point. But anyway, we're going to make a function called hello world. It's going to take one argument, PyObject star self. And this self argument, when you're working in a C extension, this will be a reference to the C extension module itself. So you're kind of defining methods on the module here, or at least that's kind of how it looks like in code to me. But anyway, we're going to make this hello world function. We're not going to take any arguments. We're not going to do any logic here. We're just going to do the simplest thing possible, which is going to be returning a new Unicode object. The way you can do that is with PyUnicode from string, and we're just going to do hello world here. Now note that it says Unicode here. This name actually carries over from Python 2, but it is actually the stir class in Python 3. We're also only targeting Python 3 in this case, so I'm not going to show you. You can do some little if-def tricks to make it work in Python 2 as well, but we're not going to do that. But yeah, the C API didn't really change much between Python 2 and Python 3 because they wanted to maintain some backwards compatibility there. And in Python 2, the Unicode object was already acting like a Unicode object, and the string object was already acting like a bytes object. So that they chose to make the bytes object have the breaking changes and not the Unicode object. So Anyway, if you're looking for stir operations, you'll look for PyUnicode. And I usually find when I'm Googling stuff, I will search for C API, Python C API. This usually gives me the best results for what I'm looking for. But when I just started out writing C extensions, I was very lost, and those docs are actually pretty helpful. Okay, so this is our method. We need to do a bunch of boilerplate to actually set this method up so that you can call it when you import this. And the first thing to do that is the method definitions, and py method def methods. And so you will start by making an array of method definitions, and a method definition is an array of structures, and the last structure is actually null terminated. So it kind of looks like a null terminated string, but it's actually a null terminated array. And these are structures that have 3 parts, or at least the example that I have today has 3 parts. The first is the method name. So even though this is underscore prefixed here, I usually like to underscore prefix these just because I don't want them to be, exposed. Also static will make them not exposed either. But so the first part is the function name. The second is the actual function, and you have to cast it to PyC function. I don't remember why, and I don't remember if it's actually necessary. We can actually try that later. Probably won't try it later. we'll just cast it. That's what the example says to do. And we'll have method noargs. I'm actually copying from some code that I wrote for myself as notes a long time ago, but I'm rewriting some novel code today, so that we'll see the novel code in a second. So things will probably go wrong when we do that. But anyway, this is the list of methods, and you'll note here that we have this structure that null terminates this. I think you can actually, do 3 nulls here, but it really only checks these, I think, the first one, so it doesn't actually matter so much. But this is just so that the C machiner can know when to stop in this array. The next thing that we'll make is static struct py module def. This is the module definition. And yeah, this is why I'm copy and pasting this, because some of this is just stuff that you're going to have in every single one of these. So you start with this macro head init, you give it a name, and again, this is going to match the module name that we put in setup.py as well as the file name that we have up here. This next field is null. I don't remember what it's for. This next field is -1. Again, I don't know what it's for. And then finally, we're going to list the methods array that we had down here. These are probably more advanced topics and things that I just don't understand, but that's okay. You don't need to understand them to make a very basic C module. And then finally, the last part of this is the public initialization of this module. And the way you do that is with this special py mod init func macro. And you define a function for the module initialization, and you do that by prefixing it with py_init_. Note that this prefixes it, so you're going to actually put your module name after this. So sometimes you'll end up with 2 underscores in a row. So this is the module name, this is the prefix. I always mix this up, so make sure, like, if your module starts with an underscore, you'll actually have 2 underscores there. And this is void, and this will return a new module object. And usually you can just do that by doing return pymodule create with a reference to the address of your module, basically passing a pointer in here, because this is a structure, this is a pointer to that structure. You can also do other stuff in your initialization, like if you need to, import other modules or attach attributes, you can actually assign this module object and then attach objects later. We're not going to show that today because we just want a very simple example. And I think this is enough to actually demo our little hello world thing here. So I'm going to pip install dot. Note, you can editable install, but it doesn't really mean much for a C program because you're going to need to recompile the C anyway every time you want to make a change here. So I skip editable installs here and I just do pip install dot. So this is going to reinstall everything over and over and over. And you'll notice that we've got a little typo. This is actually one kind of nice thing about writing a C extension is when you make mistakes, the compiler can point out some of those mistakes. So I was missing an equals there. That was not intentional. Okay, but now we have this installed. Should be able to do import underscore hello and call hello.helloworld. And it should return the string hello world. Perfect. So we've got, the most basic C extension possible. Now I want to actually introduce 2 other concepts. One of them is argument parsing and the other is reference counting. So we're going to actually add another function, which is going to look similar to this. This is how I would write it in pure Python. We're going to call it hello, and we're going to have a positional only argument, because this is the convention in C is like a lot of things are positional only just because that's easier to write. And we're going to pass in a name, and we're going to return, oops, is that not how you do positional only arguments? Is it like this? I should know, I did a video on this. I guess it's like this. So name is positional only, and we're gonna make a string which is hello, and then I don't usually like to use percent format, but it's more convenient at C level, so we're gonna do it there. Name.upper, and then return S. So this is the function that we're going to try and implement, but we're gonna implement it in C. So this is what that function does. But this is what we're going to try and implement in C. So I'm going to make another method here. Static pi object star hello pi object star self. We're actually going to take arguments here. So we're going to have another thing here, args. And again, returning a pi object star. We're taking a tuple of arguments. This is what the C machinery will call us with here. And again, we're going to get our module object here. We don't really care about that. We're going to ignore it. And we also need to add our method down here to our method list pi_c function hello. This is not going to be meth no args. It's going to be meth var args. This means that we'll take a variable number of positional arguments. There's actually a bunch of different macros for this slot. You can take positional arguments, you can take keyword arguments, you can take both. There's actually like new stuff like vector call, which changes this as well. But we're just going to take, variable arguments for today. And the first thing that we want to do is we want to parse this argument tuple. I would read the docs on this because it's pretty complicated, but the function is pi_arg parse tuple, and it takes essentially a format string and a bunch of pointers, and it will assign out various parts of this argument array. Argument tuple, and we only care about one argument today, which is this name argument, and we want to take a string there. So what we're going to do is we're going to declare a variable. This is what we're going to assign stuff into. We're going to call pi_arg parse tuple. We're going to pass args in. We're going to pass a format string. This u means that we're looking for a stir object, and it will keep it as a pi object. So we'll continue to have a pi object here. And then we need to pass the pointer to that so it knows where to assign it to. So this on its own will parse that argument, and if there are errors, this will return null. And so you'll see this convention a lot in Python where a C function will return null, and so you should turn that into an exception. You should propagate that null. And so you can say if not pi_arg.parse tuple this, oops, get rid of that semicolon, return null. So basically this says, like, if it returns null, there will be some sort of exception, and we'll repropagate that by returning null here. Let's actually just not complete the rest of the function and demo just that bit working so far. So we're gonna parse this, but ignore the return value here, and just, hello world. So we'll reinstall now. And if we import hello, if we call hello.hello with a string, so say like foo, you'll see that it allowed this value, but if we passed in like 1 here, pi_arg parse tuple will return null, and then we will return null, and this type error, which is what pi_arg parse tuple is set, will end up showing up here. So this is kind of just like our very basic thing. It also nicely makes an error message for you. So it says like argument 1 must be stir, not int. I think you can actually give these names like this or something. I don't know, but we're just gonna do positional arguments. There is a way to give them names, but we're not gonna bother with that today. Okay, the next thing that I want to show you is calling a method on this. So we're gonna uppercase this value. Again, this is arbitrary. I just wanted some silly example that showed somewhere where I would need to do a reference counting thing. So we're gonna create a temporary intermediate string by calling the upper method on that name Unicode object. And so we're going to do pi object star upper. This is the uppercased value. This is our temporary value. And we're going to use the object protocol for calling methods. Pi object call method. And the way you call a method is you pass the object in, you pass the string of that method name. And so in this case, the method is called upper. You can also pass arguments here, so you can do a format string. So say if I needed to call something with a Unicode object like this, I would do that. We don't actually pass any arguments here, so we can pass null here. There are actually shorthand methods for these in Python 3.9, like there's call method 1arg. But I'm working in Python 3.8, so we don't actually have those nice things yet, so we have to do this. And this uppercase is our method. Now it's possible that, again, like, it's possible that this returns an error, and so we do need to check that this is not null after this, and if it maybe became null, like such as a memory error or any sort of other things, or maybe this wasn't actually a Unicode object, it was something else, or maybe upper raised an exception. There's a whole bunch of ways that you could run into errors here, but it's always a good idea to check when something could return null, whether it is null, and then propagate that error. So we can say here, if upper, if not upper, if upper is null, again, propagate that exception by re-returning null ourselves. Now, in this case, upper is always going to be present, so this code is, shouldn't be reachable unless there's some sort of weird memory error. But I want to show you what it would do if we would intentionally make this wrong, just to show you that the error handling does actually work. And so we're going to reinstall again, and we're going to do Python import hello. If we did hello.hello world, you'll see that this PyObject_call method tried to look up the upper ASDF method, and it failed, and so this was null, this was true, and so we returned null and propagated that error there. You can see here that stir object has no attribute upper ASDF. Cool. Okay, so we've shown calling a method, we've shown error handling twice, and the last thing that I want to show you is creating a new object and managing the reference counts properly. So we're going to create our new object, PyObject_ret, and we're going to use PyUnicode from format. This is kind of the low-level formatting API for Unicode objects, and we're going to do hello %u. This %u should actually look familiar because it's the same format code that we used up here in PyArg parse tuple. I think they're mostly the same. There might be some that are slightly different, but it knows to parse this and does some magical stuff there. But we're going to format in this upper string, and then we're going to return this value. But you'll note, or if you've worked in C extensions before, you'll note that I actually have a bug in this function, even though this function works properly. So let's just show that working properly, but I'll show you what the bug is here. Python import hello Anthony. And it should say hello Anthony. Cool. Now, even though this works, interestingly, this is actually leaking memory, and this is another reason why you probably don't want to write C, because it's really, really easy to make mistakes like this, and this is a very simple function. What's actually happening here is this PyObject_call method, when we created the uppercase string here, this actually allocated a new object, and it set its reference count to 1, so this upper string is actually referenced, and when the way Python works is that each object has a ref count on it. Actually use sys.get ref count. Why is that 3? It seems bigger than it should be. Oh, because it leaked. Yeah, of course. And so you can use sys.get ref count. This is again C Python implementation details. This won't work, for example, in PyPy. But if an object has a non-zero reference count, it won't get garbage collected, and so that memory will stay used even if it doesn't have any references. So like we created this as kind of a temporary variable, and then it never got cleaned up. So what we need to be very careful about is we need to decrease the reference count when we're no longer referencing this. So after this line here, we no longer need this upper string, so we can call pydecref on this value, and so that'll decrease the reference count on this, and so we'll no longer be referencing this. So that'll fix our memory leak there. And after all of that, import hello Anthony. Cool. And that works. Okay, so anyway, this is kind of a long-winded explanation, but this was the the C extension that kind of demos 3 different concepts, like defining methods in C, parsing arguments, dealing with errors, and dealing with reference counts as well. And again, I would not necessarily recommend writing a C extension. You're probably better off writing some other higher level representation that either compiles to native code or compiles to C++ or C, or translates, I guess, because you wouldn't really compile. C would be a compile target. But anyway, I wouldn't necessarily recommend this, but this is how you might write one. But anyway, hopefully this was helpful. If you have additional things you want me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.